Here's some more examples of dividing rational numbers, also known as fractions here. So I'm going to go ahead and get started. Also, if you're having a hard time with multiplying fractions, this is a great video for you to watch because once we do our keep, change, flip, we're going to be multiplying everything. So just to review, keep, change, flip is, in this first example, we keep the first fraction, we change our sign to multiplication, and we flip the second fraction. Something that a lot of people forget about whole numbers like 3, it's still technically a fraction. All whole numbers can be put over 1. So I can rewrite this problem as negative 9/10 because we keep the first fraction, we change the sign from division to multiplication, and we flip the second fraction to 1 over 3. So that is our keep, change, flip right there. Then what I'm going to do at this point, I'm going to use cross-cancellation. I have a 9 on the top and a 3 on the bottom. I can divide each one by 3. So 9 divided by 3 gives me 3. 3 divided by 3 gives me 1. And then I multiply the two top numbers, multiply the two bottom numbers, and my final answer is going to end up getting me negative 3 over 10. That's the final answer for the first one. And remember, when you cross-cancel here, you do not have to end up simplifying your final answer in the end. All right, let's go ahead and look at the second problem right here. Same scenario, keep, change, flip, except I would like to change this to an improper fraction. We always keep that negative there. Negative is going to stay the same, but we're just going to focus on this 1 and 1/3. The denominator of my fraction is 3. That's not going to change. But then what I'm going to do is I'm going to multiply my bottom by the big number. 3 times 1 is 3. Then I'm going to add my top number. 3 plus 1 is 4. So this is the same as this. I just rewrote it as an improper fraction. I'm going to change my sign to multiplication. And then I'm going to flip my second fraction to be 3 over 2. Now I'm going to go ahead and use my cross-cancellation. Notice how I have a 3 on the bottom and a 3 on the top here. Those can cross out. I also have a 4 on the top and a 2 on the bottom. They can both be divided by 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. So when I multiply what's left over on the top, I will have a negative 2 over 1. This is the only case in where you have to simplify after cross-cancellation because negative 2 over 1 is the same thing as negative 2. It is a whole number. Any number over 1 is a whole number. So we've got the same scenario here. This is kind of like a combination of what we've had here and here, except here we got two negatives. Whenever we divide two negatives, we're going to get a positive. So kind of the cool thing here is we know our answer is going to be positive, so we can just change that to a positive. We're going to keep the first fraction, 1/3. We're going to change the sign to multiplication. And then we have to flip this second fraction. Now I'm going to show you guys a shortcut. This is a mixed number. We have to flip it. So instead of that 5, the denominator being on the bottom, it's now going to be on the top. Only because we have to flip it. Keep, change, flip. That's very important. So 5 times 1 is 5, plus 1 is 6. So if I were to change this into an improper fraction, it would be 6 over 5. But because I had to flip this fraction, I automatically flipped it to 5 over 6. I just did 2 steps in one. And looking at these fractions, I can't cross-cancel anything. So I just multiply the tops and multiply the bottoms. So 5 over 18 is going to be my final answer. One more to go. We're in the home stretch. So this is a slightly easier problem right here. We don't have to change anything. We don't have any negatives, but it is a really good problem for cross-cancellation. So we're going to do keep, change, flip. We're going to keep the first fraction, 3 over 25. We're going to change the sign to multiplication, and we are going to flip the second fraction to be 15 over 2. Now the reason why it's a good example for cross-cancellation is all the other examples. For instance, up here, one of these cancel out to become a 1, or they cancel out completely. Here, that's not going to happen. The greatest common factor between these two is 5. So I can divide the top and bottom by 5. and get 3 over 5 times 3 over 2 once I multiply those, or once I cancel those out. So my final answer is going to end up being 9 over 10 once I multiply the tops and multiply the bottoms.